Hey everyone, so this is our last new lesson before our test. So it is understanding linearization of a function. It's really straightforward. You won't have much trouble with this at all. Alright, so pause and do the do now. So if y equals 7 is a horizontal asymptote of a rational function, then which of the following is true? So this one, if you go back, just go back to our definition of horizontal asymptote. Horizontal is this way, right? So if we're going towards it, so it's as x approaches infinity, right? And then there's two that involve infinity. There's b and e, but e has -7. So the answer is just b. Okay, so what is linearization? So the whole idea here, it's just really a fancy way of describing a tangent line. When you get really, really close to a function, it basically blends in with the tangent line. So in this example, like we're zoomed out here, but if I zoomed into like here, it's almost the exact same thing. The curve starts to look exactly like a line. So, and we can use that to kind of estimate the function. So if it's a really complicated function, we don't have a calculator, we want to figure out what's the value of the function, we can use the tangent line to do that. And that's called linearization. It's really just a function that's a rehash of a tangent line. All right, so here is the theorem for linear approximation. So like I said before, this is just another way of saying the tangent line. So think of the L of x as our y. F, that's our little y, our y0. F prime, that's our slope. And then x minus x0. So all it is it's the tangent line where the y0 is brought to the other side, just so we can call it a function, right? You can't, L of x minus y0, that's just weird. So we bring the y0 to the other side and we write it like that. Right? So that is linearization, just tangent line where the y is moved to the other side. Okay, so find the linearization, the linear approximation L of x to f of x equals sine of x. So we're finding L of x, so we are finding a tangent line. So at a tangent line, we need a point and we need the slope. So our x is 0, sine of 0 is 0, and then we need our slope. So what's f prime? Cosine. And then plug in your 0 to find your slope. We get 1. So the equation of our linear approximation, L of x, is just x, right? Slope is 1. All my other points are 0. So then we can use that to estimate the value of sine at those points. So L of negative 0.3 is just because it's x, negative 0.3. L of 0.1 is 0.1. L of 0.4 is 0.4. L of 0.5 is 0.5. And L of pi over 4 is pi over 4. So now we can check. Let's see how accurate this is. Sine of negative 0.3 is negative 0.2955. So that's pretty accurate. Sine of 0.1 is 0.0998. So again, really accurate. Sine of 0.4, 0.389. So we're getting a little less accurate. Sine of 0.5 is 0.479. So even more inaccurate. And sine of pi over 4, we should know, is root 2 over 2, which is 0.707. And then pi over 4 as a decimal is 0.78. But that makes sense because as we get farther away, if we look at the sine curve, right, and then we have our tangent line, right? The farther away, the bigger gap there's going to be between the curve and the graph. So when we're getting to pi over 4, which is here, I didn't do a very good job graphing this, there's going to be a larger difference between the actual function value and the linearization. All right, so try this one on your own. So we need a point. So this one is a little tricky. Use a linear approximation for f equals the square root of x to estimate the value of 66. So notice it doesn't give us a point. So you want to think what point is close to 66 that we know. Well, if I took the square root of 64, I get 8, right? So I'm going to use the square root of x at the point 64, 8, to estimate square root of 66. So we have our point, f prime, 1 over 2 root x, f prime of 64, 1 over 2 times 8. So my slope is 1 over 16. So L of x is my y value 8 plus my slope x minus 64. So now let's plug in that 66 and let's see what we get. 8 plus 1 over 16 times 2. That's 8 plus an eighth. So that's 8.125. Now let's actually plug into our calculator. What's the actual value of root 66? Root 66 is 8.124 is the actual. So that's really close. So back in the day before calculators, this was a really good method for estimating. Okay, try this one. What is the linearization at x equals 1? So again, we have our point, x. What's the y value? When I plug in 1, I get e. F prime, what's the derivative? E to the x. F prime of 1 is e. So my slope is e, my point is e. So we have L of x equals my y value. Oh wait, what's the linearization? I have to plug in. Oh no, I do. I'm writing the equation. Sorry, I'm confusing myself. E plus my slope e, x minus 1. Simplify that. E plus ex minus e. The e's cancel, so my line is just ex, which is b. So again, we find our point, we find our slope, and we plug into the linearization, the equation of a line. All right, try this one now. All right, so we have 0, 1, and they're giving me the derivative. So that's not the original, that's the derivative. So then f prime of 0 to find our slope. That's cosine of 0, which is 1. So our linearization is our y value, which is 1, plus my slope, 1, x minus 0. So it's just x plus 1 is my linearization. So then I can estimate L of 0.1 is 0.1 plus 1, 1.1. Right? So that's my answer. And I don't even know what the original function is, so I can't check. I have no idea whose derivative is cosine of x squared. Okay, so now here I took this from a free response from 2002. So before you guys were born, or maybe the year you guys were born. I was a freshman in college when this was given. Okay, so write the equation of a line tangent to the graph at the point where x equals 1. Use this line to approximate the value of f of 1.2. So this is what typically you see, is this will be a section of a free response problem. So we're using x as 1. What's the y value at 1? The y value is -4. And then what's my slope? My slope will be 5. So L of x equals -4 plus 5 times x minus 1. So that's my tangent line, or my linearization. And then I'm going to plug in 1.2. So -4 plus 5 times 0.2. Let's see, -4 plus 1, so you get -3. And that's the answer. All right, last one. Again, this is from 1997. This is an multiple choice problem. No calculator. So they're giving me the point, 3, 2, and m is 5. If the tangent line at x equals 3 is used to approximate to a 0 of f, what is the approximation? So we're going to write our tangent line. You can write y equals 2 plus 5 times x minus 3. That's my equation. Now I'm approximating a 0 of f. Approximate the 0 of f. So that is the y value equaling 0. So 0 equals 2 plus 5x minus 15. So that's 5x minus 13. So x is 13 over 5. So that's 2.6. So C. So the idea here is you have some curve, right? And then you're finding a tangent line and estimating where the tangent line crosses the x-axis. And that's useful if it's really hard to solve the quadratic. All right, so I have a worksheet. It's actually just problems from your book. It's practice AP problems. And that's it.